Okay, so you said that the input was of sine was the angle swept, the measure of the angle swept counterclockwise from the 3 o'clock position. Okay, output, Miguel, what's the output of sine?
The output of sine will give you the radius length above the horizontal diameter.
Radius lengths above the horizontal diameter. Molly, you agree with that? Yeah, okay. So now, the reverse process, how could you explain the meaning of the reverse process? Okay, so we got 3. Odd number of people. So how about not a competition. I just thought you might pair up, but we can't quite even pair up. But let's see. Doesn't matter. Melissa, will you go with Alfredo? And then how about Gina and Lee? And then you 3 can be up there. So let's see. Lee, you come over here, and Molly, you go over there. Okay, so talk about what the reverse process would be like. Go. What would the reverse process be like?
So I think the reverse in the vertical distance above the horizontal diameter and the radius something like that. Yeah, so the inverse would be the inverse.
So we're thinking of and this one you put the degree, right?
Yeah.
What are the regular sine functions or the reverse or the inverse? What do you think? The
radius.
The radius?
For sine,
Okay, Miguel. Pedro, sorry. I already called on you, right?
Yeah.
Okay, Pedro. So explain the meaning of the reverse process. So what would the reverse process F inverse be in general?
In general, it's a process where you use the output as your input.
Talk to me about exactly what quantities the reverse process has to do with. So what does the reverse process do in terms of specifically the quantities involved? Don't compare it to F. Think of it as its own separate process. What process does it perform?
In general, not using sine now, nothing like that.
No, well, it is the reverse process of sine. But I don't want you to talk about sine. I want you to talk about this, the reverse process of sine. What does it do?
You take in the vertical distance.
Okay.
In order to get the angle measure.
It takes the vertical distance and gives the angle measure. Right, and we'd have all the other details too. The vertical distance above the horizontal diameter and radius lengths, that's what it would take. And it would give the measure of the angle swept counterclockwise from 3 o'clock. Okay? So right, so that's there. Okay, so here we go. Explain the meaning of the expression and find the value. Okay, explain the meaning of each expression and find the value. You don't have to whisper. Yeah, all four. Okay, Gina, what do you think about this first one here? Reverse process with an input of 1. What does it mean?
I said that when the input is 1, 1 is the radius length above the horizontal diameter, and the angle swept counterclockwise from the clock position is 1.
The angle is 1? Okay, what do you think about that, Molly? She said when the this represents the vertical position in radius lengths, and then that would give the angle measure, which is 1.
I think the angle measure actually is 2 pi, or pi halves,
Pi halves.
because about the opposite way, the sine of y equals 1, and sine of pi halves. So the opposite would be the sine inverse, or arcsine of 1 would equal pi halves.
So is this kind of situation we're looking at here? Input is y equals 1, and then we're asking angle swept counterclockwise to get that. So do you want to change your answer to pi over 2? She's saying pi over 2.
Yeah.
Pi over 2. Okay, what about 0? Lee.
So that would be the when the vertical height above the horizontal diameter is 0,
Okay.
and that would happen 2 times when the angle measure is both 0 and pi.
What do you think about that, Melissa?
I like it.
Happens 2 times when the angle measure is 0 and pi. So this one we said is pi over 2. Okay, how about Alfredo, radical 3 over 2?
That's the distance above the horizontal diameter.
Yep.
So then the angle would be pi over 3. And then 2 pi. So it would be at that height twice.
Okay, so these two had two answers. Well, let's just go on. So what about pi? Melissa?
There is no answer because pi would be how many radius lengths above the horizontal you are,
Okay.
but there is no point where you're 3.14 radius lengths above the horizontal on that circle.
Because the maximum you could be is 1. So that one doesn't exist. These other two, we said there were two answers, but at 1, there's just one answer. So given a vertical height of 1, there's just one angle pi over 2 that corresponds to that vertical distance. Agree? Nothing more to say?
The only other time it would be at 1 is if it goes like around again, basically.
So there's one other time.
Well, just like every time it goes around.
Every time it goes around.
It'll be, there's only once that it hits the highest point.
Okay. So one answer per period.
Unless it. Or,
Did I specify
yeah,
one period?
No.
So given a vertical distance in radius length of 1, what is the angle swept counterclockwise from 3 o'clock? So there's lots and lots of answers, right? So so Melissa was going to write an expression. She's going to give me an expression that gives them all. So what would it be?
Pi over 2 plus 2 pi times n, where n is the number of times you've gone around the circle.
And out of space. So there's really lots and lots of answers, right? If n is any integer, negative or positive, right? We get all these different, over on that right-hand graph, right, it'd be all these x coordinates that would give that y coordinate. Okay, so what about 0? How many are there? 2 per period, but still an infinite number, right? So here's radical 3 over 2. Again, you look, all these different x values over here are like outputs of the reverse process, right? So there's lots of outputs for the same input. So is this process a function? This reverse process, is it a function? Yes or no? No, right? So for a given input, which is like our y value now of the original sine graph, there's lots of x values. The reverse is not a function. So in order for it to be a function, so we know our inputs are y coordinates. What do we need? We need one output, one angle per input. So we need to hit all the inputs. So what is the domain of this reverse process? What's the domain of this reverse process, Miguel?
Well, the main will be just negative infinity to positive infinity.
Negative infinity to positive infinity. Let's see. Molly, you agree with that? That the domain of the reverse process would be negative infinity to positive infinity.
Negative 1 to 1.
So what was our input quantity again? Just what quantity was it?
The vertical distance from the horizontal diameter.
Above horizontal diameter in?
The output is
No.
in radians. And the output is
Hold on a sec. I'm just asking about the input. What is the input measured in?
vertical distance from the horizontal diameter. So it's
In what unit?
in
It's not radians. Radians is openness, right? It's angle measure. So it's
radius length.
radius lengths. Okay, so if it's the vertical distance and radius lengths, what's our domain or all possible inputs of the reverse process?
Negative 1 to 1.
Negative, and that's what you want to change to, right, Miguel?
Yeah.
From -1 to 1. Here's our lowest right here, and here's our greatest input. So what we need for this to be a function is we need to include all inputs from -1 to 1, and for each of those inputs, we need to get just one angle. We need to get just one angle out for each one of those inputs from -1 to 1. And we'd like that to be a continuous one more time, let's go out once. So we need a continuous range of angles so that every single input from -1 to 1 is assigned one angle. So what can we do to achieve that? So we need one continuous interval of the angle so that every possible input from -1 to 1 is assigned just one angle. Has anyone not seen this before? And that's actually kind of good if you haven't ever seen this before. You've all seen this before.
This way.
This being done.
Okay, I know, but just the reverse process of sine. Do you remember it? Not really. Okay, so not really. So can we figure out one interval of the angle such that every input from -1 to 1 is assigned just one of those angles?
Would it be one side of the unit circle? So like negative pi halves to.
So you're saying about one side, you're saying left or right side? He's saying either the left side or the right side. Does that do it? Okay, so if it were the right side, the left. If they're the left side, then what would a range of angles be?
Pi halves to 3.
Pi halves to 3 pi over 2. Would that do it if we chose that? Okay, and if it were the right side, what would it be? Somebody else. Negative pi over 2 to pi over 2. Okay, so if we look over here, negative pi over 2 to pi over 2 is this part of the curve right here. And then the first choice was pi over 2 to 3 pi over 2, which would be starting here and going down like that, which would both be viable choices. Okay, but so which is better? Let's consider an input of 0. So if we made the input 0, like that, what would you say the output should be? What angle? For an input of 0 vertical distance, what would you say would be the natural choice for the angle? 0 would be the natural choice instead of pi, right? So in that case, what range of angles do we want? Yeah. So are you ready? This is what they're missing. I hope that wasn't a letdown. My big lead up. So we focus on, in the reverse process, we just chop off angles from negative pi over 2 to pi over 2, which gives us one angle per input value of vertical distance. And so we're just going to take this section of the sine curve. Thinking about that for the reverse process. So now let's go back and look at these and do these again now. So now I want you to answer these again. As this now function, now we defined it as a function, right? By chopping off this range of angles from from negative pi over 2 to pi over 2, we truly have a function. So now what would these function values be? Let's do something. Okay, let's make this a little more interesting here. Okay, so that one's now negative radical 3 over 2. Okay, so quick. So what would f of 1 be? Gina?
Would it be just the pi over 2?
Pi over 2 only. What do you guys think? Yep. F of 0. 0. F of negative radical 3 over 2. Negative pi over 3. What about 5 pi over 3? That gives a vertical distance of negative radical 3 over 2. About 5 pi over 3. Yeah, so it's not within a range. That's one of the other ones, right? So it's got to be negative pi over 3 to be in a range. And then what about this? Still doesn't exist. Because that's not in the domain, right? That's not in the domain. It's outside the domain. Okay, so what's the domain of, this is the arcsine, right? The inverse sine function. What's the all possible input values of arcsine? Here you go.
All possible input values?
Yep.
So it'll just be from negative pi over 2 to from negative 1 to 1,
Negative 1 to 1. Including or not including?
including.
Okay, range. Pedro.
The range, it will be negative pi over 2 to pi over 2.
Okay. Including or not? Including, right. Okay, so here's some great exercises to see if we get it. Okay, go. So then this is the order's kind of specific. So A, B, C, D, E, F, G, H. So go across the rows as you work. Okay?
This ends.
No calculator. All right, why don't you share what you've done? See if you agree with your neighbor. I changed C from pi over 2 to pi over 3. Which doesn't really change the problem, just change the number.
It's not in this quadrant, so basically you get that value, and then, so that sine function will give us that distance, which that distance is the same as that distance, and therefore the answer is that they're pretty much all the same. Just dealing with pi, because that would be from here to here is pi. That's that distance. This here to here would be just the angles. That angles is 80 minus that. Like half. Use the fact that it comes down here. I know that a certain distance from there. This is a distance from there. It's a certain distance from there. That angle.
You guys have a calculator? If you have a graphing calculator, check F. Check your answer to F. Actually, set your calculator to degrees and put that expression in and see if it does what you did. So set it to degrees. You hit mode, right? It's like the third one down. Does it do it? Yeah. So I'm not lying. This is how it works. So what's going on with these problems? Are these good problems? Why? So what's going on with these? What's that?
They make you think.
They make you think. Can you be more specific?
You have to first figure out what like the inside of arcsine is, so what the input is
Okay.
to arcsine, and then remember that arcsine only goes from negative pi over 2 to pi over 2 in range.
Okay.
So you can't just take away, like since it's arcsine and sine, you can't
Right.
just take those away and say it's just an angle.
And what do the students do?
They just can't.
Boom. It's like, oh, this is sweet, right? Yeah. So I in the past I used to start with I used to put C. I used to do that first, but I think it's better to give them one that's actually different first instead of one that's like that. Okay, so how about any through F? So what did you get for F?
Negative 71
-71
degrees.
degrees. Can you explain what's going on there? Is that what you got, Molly? So what's happening? 251. Where is that? What quadrant's that in? And are we closer to the top here of the quadrant or the bottom? Okay, because we're what? 19 degrees away. So maybe 19 degrees, I don't know, like this. And so what will sine of 251 give you? Generally, so just a description of what will it give you. sine of 251. There you go.
Measure in arc length above the horizontal diameter.
Measure in what?
In arc length and radius length.
Okay, so can you be more specific? Can you make an estimate?
It's about maybe 0.9 or negative 0.9.
Negative, yeah, something like that. About negative 0.9.
Yeah.
Do we need to know that value? Do we need to get it? No, because what are we going to do now? Alfredo. So we got this number, which is sine of 251, which we're approximating as about negative 0.9. So what will the arcsine be?
Will be negative 71.
What?
Negative 71.
How'd you get that?
Well, because it can't be 251 because it's outside our domain.
Okay.
So we need this angle that'll give us the same vertical distance from the horizontal diameter, but it's within our domain.
Okay. And how do you figure that out? Like, what to get that number 71? What did you do in your brain to get that?
Well, you were 19 away from 275.
So you looked at this angle right here as 19 degrees. Is that what you're saying? First?
Yeah.
Okay.
And then, so I needed, and the angle that would be within our domain would be 19 degrees to the right of that.
Okay. Keep going.
And then the angle sweeping from the 3 o'clock position to where that mark is clockwise would give us the same position as 251.
So, what are you doing to get that angle? So what is that?
Oh, subtracting 19 from 90.
90. Right. You got 71, but it was negative.
Yes.
Anybody think of it a different way? Everyone did the same thing?
I first took it from 180.
Yeah.
And did 251 minus 180.
Yeah, this is actually more direct, kind of more direct. Well, I guess it's about the same. So you look at this angle,
Yeah.
which was
71. Which would be 251 minus 180. And then since I knew it was going to be sweeping clockwise from the 3 o'clock position, I just made the 71 negative.
so it's the same amount of openness, but now sweeping this way, negative 71. Yeah, both are valid. Okay, what about arcsine of 2? Lee, can you talk me through arcsine of 2? Or sorry, arcsine of sine of 2.
Right, so sine of 2 would be, sorry, 2 radians, I assume, right? So that would be somewhere in our second quadrant.
Okay, more towards the top or more towards the bottom?
I think more towards the top, but pretty close to the halfway in between.
Okay, you like that?
And I knew that that height is what I wanted, and I needed to find the other angle that would give me that same height. So I knew that it would be pi to get all the way around to the,
Okay,
so that it would be 0. So I did pi minus 2,
pi minus 2.
and that would be that angle. The other one would be the same angle, so it's still a counterclockwise direction.
Like this? Pi minus 2. Agree? Cool. Okay. How about the last one? Sine of 6. Who wants to do this? I feel like I'm calling on everyone so many times, and that's because there's not very many of you. Molly, you want to try pi of 6 or sine of 6?
So sine of 6 would be in the fourth quadrant, closer to the horizontal axis.
Okay.
And you would take 2 pi minus that number.
And what would that represent?
It would represent that angle between the horizontal diameter and the right.
This one here?
Or
Okay.
and that would be, but then you make it a negative because it's going counterclockwise.
That?
And that would be your angle.
That would be right. Negative quantity 2 pi minus 6. Good. Nice. Or we could do 6 minus 2 pi then, right? 6
Yeah.
minus 2 pi. But yeah, no, but this is, I like, actually, I kind of prefer it like this because it kind of shows the process. It makes sense. Let's see if I can find my, forgot about this, but I just remembered. Who's up? Pedro, describe for me the reverse, oh no, you did the reverse process of, so we'll do someone else. Alfredo, what is the reverse process? If G is cosine, then describe for me the reverse process, G inverse. What would it do?
The inverse process would take the output of G. And
No, talk about the quantities.
Okay.
So don't talk about G or cosine. Talk about the quantities that it would, the process it does according to quantities.
So it would take the horizontal position to the right of the vertical diameter and the radius lengths,
Good?
and it would give out the angle swept from counterclockwise from the clockwise.
Okay, good, excellent. So it's going to take, it's going to, now the input's going to be x coordinate, and its output is going to be angle. Okay, so input x coordinate, output angle. So same thing, we need, in order for this to be a viable function, we need one continuous interval of angles so that, so the input, what are the range of values for the input of this reverse process? Melissa. -1 to 1. Yep, so from -1 to 1 is going to be all possible inputs into the reverse process of cosine. Okay, and so we need a range of angles so that for every one of those inputs from -1 to 1, we get just one angle out. We just get one angle out. So, Gina, can you see what range of angles we want to use? 0 to pi. So can you kind of say more? Why would that be?
Because it's going to give everything above the vertical, I mean the horizontal diameter. It's going to give you 1 point above the horizontal diameter.
Okay. Yeah, so like the top half of the circle gives you one angle for every input -1 to 1. And is that consistent with, so for an input of 1, what would we want as a logical choice? If the input was 1 radius length to the right, then we want what angle, logically? 1, 0, okay. So there's our deal for our cosine. Okay, so what's the domain of arccosine? Pedro, what's the domain?
The main is from -1 to 1.
-1 to 1, and what's the range, Lee?
0 to pi.
0 to pi. Okay, so let's do these. I just have 3. Go for it. Was it 251 before?
Yeah.
Let's do the same one. Okay, Melissa, talk to me about arccosine cosine of 4 pi over 3.
So cosine of 4 pi over 3 is going to be in the second quadrant, closer to the horizontal diameter.
Are you sure?
Oh wait, no, sorry, third quadrant, closer to the horizontal.
4 pi over 3. So 1, 2, 3. I think we're down like here, right?
Yeah.
Okay, so there's 4 pi over 3.
be the same horizontal distance. If we draw a line up from that position, it's about like -0.6 radius.
Well, what I did, but we know exactly what that is. What is that? 4 pi over 3.
-√3/2. -0.5, yeah.
Okay.
So if we want it to still be -0.5, I did 4 pi minus 3, or 4 pi over 3 minus pi to get the distance, the angle from pi to 4 pi over 3.
Okay, or you could just, can you just apply your unit circle? Since we know that's -0.5.
Could be 2 pi over 3.
Yeah. So we're saying, what's the angle from 0 to pi that has this same x-coordinate? Right? The subtraction's okay, but on one like this, we can just apply our unit circle backwards.
Do you have your Mat 170 students memorize the unit circle?
I had them do the whole thing, yeah.
Okay.
Yeah, I did a quiz. They had to fill the whole thing out. I didn't spend a lot of time on it, but I quizzed them. Like, they had a recitation quiz. They don't know them, do they? The students in the... And why are you asking that?
Well, I was just wondering because last week when I was tutoring someone, it was in one of the other classes, and they were already working on some of this stuff, and they didn't know any of the
Right.
unit circle at all.
Right.
Because it was trying to get them to like kind of try and estimate some of them, but give like exact answers.
Right.
And they didn't know what any of them were.
Yeah, to get exact answers on these key angles, you need to know your unit circle. Yeah. So, I go through the, did I show you the animation of counting? Like how the counting thing? Did I show you
Can
that?
you show it one more time? Because I really liked it. And I was trying to explain it to somebody and I messed it up.
Okay, after class.
Okay.
We'll do after class. But yeah, I go through that with them actually in 2 different classes. I don't spend a lot of time on it, and then they have to take the quiz and recitation. So, all right, so 2 pi, are we good on 2 pi over 3? Okay, let's just go, Alfredo, how about 7 pi over 4? Talk me through it.
Okay, yeah. So 7 pi over 4 would be on the 4th quadrant, and it would be closer to the horizontal.
This?
Yeah.
Nope.
No? Oh, it'd be in the middle.
Right, halfway, right?
Yeah.
Okay.
Okay, and then I took the angle measure from 0 to 7 pi over 4 clockwise.
You want it all the way like this?
No, from the 3 o'clock position.
Right.
Clockwise downward.
Like that?
Yeah. So that would be 4 pi. Or I mean pi over 4. And then I did 1 pi over 4 up, and then that would give me the same.
Okay, so you didn't even, all right. Okay, that's cool. So you didn't even find an x-coordinate. Because that's kind of how we did these other, yeah. So that's how we do these ones at the end. Yeah, that's good. Did anyone actually find the x-coordinate? And reason about it with the x-coordinate? What is cosine of 7 pi over 4? Root 2 over 2, right? And so then what question are we asking? By taking the arccosine of root 2 over 2, what question are we asking? Lee?
What angle between 0 and pi gives you the horizontal distance is square root 2 over 2?
Well said, right? So what angle between 0 and pi would give you the horizontal distance of radical 2 over 2, which would be? Pi over 4. Okay. How about let's do this one? How about cosine of 251 degrees? Lee?
So 251 degrees is going to be the 3rd quadrant, closer to the y-axis than the x.
Okay.
And so I want to find the, so going to that vertical is again 19 degrees.
Oh, this is 19 degrees here, okay.
Yeah, that's 19 degrees. And I know that in order to get that same horizontal distance, I'm going to need go from that straight up from like 90 degrees, I'll need to go 19 degrees more.
So this has to be 19 degrees.
Yeah, that has to be 19.
Okay?
And so I added 19 to 90.
Uh-huh.
And I got 109.
Agree with that? Do it in your calculator, quick. If you haven't already. Yeah, 109, right? Cool. All right, last one, arccosine, cosine of 5. There you go.
Alright, so it's gonna be on the fourth quadrant.
Fourth quadrant,
Yeah.
towards the bottom or towards the top?
Towards the bottom.
Yep.
Yeah, around there.
That's
And-
5, okay.
And we know from the 3 o'clock position, so clockwise, that would be -1 radian.
That's -1. So
Just
6
go-
radians all the way around, that's what you're thinking? 6?
Yeah, yeah.
6, exactly
I mean,
6?
It'll be 2 pi minus 5.
2 pi minus 5.
Yeah. So we kind of take that point upward and make a line. So then the top will be so wouldn't it just be the difference?
So what angle? So what? So wouldn't it be the difference? Isn't very descript. Can you be more specific? What do you?
I don't know.
So what is our cosine? What's the input and what's the output of our cosine?
Well, the input is the radians length to the right of the horizontal.
Okay, so our input is this,
Mhm.
and what's our output?
The output will be the degrees from the 3 o'clock position. When clockwise.
Not degrees.
Or the angle measure.
Angle
Yeah,
measure.
Right. For the 3 o'clock position.
Right. So that's what we're asking for, right?
Yeah.
Which is?
Would it be just 2 pi minus 1? Because the whole thing is just 2 pi.
Whole thing's 2 pi.
I mean, pi over 2 minus 1? Yeah.
Okay. Yeah. Pedro.
It'll be 2 pi minus 5 positive, wherever you get from it.
Is this a negative or a positive value?
Positive.
That's positive. So is that the angle?
Yeah.
Yeah, that's it. I didn't say you were wrong. I never said you were wrong.
Oh, I thought
You
when I
just,
said the difference, you were
your
like,
wording
change
was
everything.
very non-confident, so I was just trying to get you to.
I thought you, yeah.
So technically that clockwise angle is negative of the quantity 2 pi minus 5, right?
Right. This is the positive openness, right? So this is the magnitude of openness of that angle. So if you were really saying what is this clockwise angle, it would be the opposite of that. The opposite of 2 pi minus 5, because that would be a negative angle. But just as a measure of openness, it's positive 2 pi over 5. That's what we want. 2 pi minus 5. 2 pi minus 5. Okay, so the whole point of this is given coordinates, then can you find angles or arc lengths around the circle? That's what you use this for. But you can't do those problems. You and the students cannot do those problems without this firm understanding of what's happening when you use arccosine and you get these coordinates in the third and fourth and second quadrants. You have to apply this stuff correctly to get the right arc length or the right angle, whatever's being asked for. And so there's the web work has lots of practice with that, and so that's what will be for Thursday. Any questions? Cool, let's go home. And if you still want to see it, if you want to stick around for the unit circle that I'm going to do for Gina, you're welcome to stick around.
So I remember we started with like.
What's it?
It was like.
Oh, I'll do it on the screen if you want to watch the screen. I'll just leave it up. So what were you saying?
So you count like 2 or 3 different times, right?
I just count twice. I do pi over 4s and pi over 6s,
Okay.
and then on the pi over 6s, then I just simplify the fractions that can be simplified.
So now the math is done.
Okay. Is it showing up? Oh. Okay, so it starts with the whole number of radians, right? Those are whole numbers, and from the whole numbers we get exactly halfway around is pi. So we start by pi over 4s, right? So this is taking that first half, the top half of the circle is pi, and so we're breaking the top half of the circle up into 4ths. So then you just count from there. 1, 2, 3, 4, 5, 6, 7, 8. And then all the ones these are easy, right? They all simplify to pi over 2. Pi over 2, pi, 3 pi over 2, 2 pi. And then we do 1/6 of the top half. So this is taking the top half and dividing it up into 6. And so then we count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So then which ones of those simplify?
The 2 pi and then the pi.
Yeah, of course the top, bottom, left, and right, but then also these, the ones that are the new ones that are closer to the top and bottom, those simplify into the thirds. And then those we know about the black ones. So that's it. So where did you get? Do you know where you got stuck?
Yeah, I couldn't remember like how like before like the denominator.
I think I must
How it, but I see it now. So you just they're quarters, so that's where the quarters come in.
Quarters of the top half. All the way around will give you, and then 1/6 of the top half coming all the way around. And in both cases, you will hit top, left, bottom, and right. In both countings.
Yeah. So it's
1, so pi over 4. 1, 2, 3, 4, 5, 6, 7, 8. And then pi over 6, you will also hit top, left, right, and left. Bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
and then I couldn't remember if when I'm counting
Yeah.
And then we'll fix it.
I will fix it, and my sister. My
if
sister
I
will
was
help us
supposed to
fix
include
it. She's
the
doing
pi
it in
over
English.
4 and the 3 pi over 4.
It's only
Thank you.
No, you don't.
Okay.
But that's
See
what
you
I was
later.
getting
Yeah, so you do not count those
because
because,
we already counted them.
well, no, but we already counted these, so that's not why you don't. It's if you're going to divide the top half of the circle into 6, then what are you dividing a quarter circle into?
Oh, okay, see.
So if this is going to be in 6 parts, how many parts do we get in the first quarter?
You get, well, 3, 1, 2.
3, right? So 3 will not include half.
That, yeah.
It'll be a third, 2/3 full. A third, 2/3 full. So a third, 2/3 full will never include a half
Okay.
of of a quarter.